Let's go ahead and make a start. We have officially a full house in front of us. I can't see a single empty seat. We've still got a few more folks coming in, but we've got a ton to get through, so we'll go ahead and get started. My name is Feddersen. I lead the product management for Postgres at Microsoft. I should say, just before we get started, the configuration of these rooms is such that we've got another breakout there, and there's one behind us as well, so the noise could get a little muffled. If you do need a little extra help hearing, they've actually got headsets at the back of the room as well that you can use for this session directly. So as you can see on the podium, we've got 4 laptops here. This is going to be a very demo-heavy session today. We're going to cover Cosmos DB, we're going to cover SQL, and we're going to spend a lot of time on HorizonDB at the end, which was our big Postgres announcement this morning. And you can see I'm joined today by Abe, Bob, and James, who are each deep experts in each of these databases, and they're going to walk you through a ton of code today. So I talked about the scope. We're going to look at Cosmos DB. Cosmos DB is Microsoft's effectively planet-scale NoSQL platform. It powers some of the biggest apps on the platform on the planet, including OpenAI. SQL, of course, long-standing enterprise adoption of Microsoft SQL platform, a phenomenal relational engine. And then Postgres, which a lot of AI apps are being built on today. So we're going to cover all 3 of these. And so let's go ahead and get started. We made a ton of announcements at Build, many that weren't covered in the keynote. This is a little bit of an eye chart, this slide. You don't need to memorize it, but at the very bottom of this slide are dedicated AKMS links that are blogs for each of these 3 databases that cover quite extensively all of the announcements that we made at the conference. And another thing that I want to let you know is that all of the code and more that you're going to see today is in a GitHub repo already. That's a screenshot of the repo, AKMS build 26 BRK223. I'll bring this slide back up at the end as well, and you can go grab everything that we show you today and get started yourself. And so with that, let's get into Cosmos DB. So the big announcement for Cosmos DB at the conference has been the Agent Memory Toolkit. Memory is one of the most important things when building your AI agents. These agents need to remember what's happened in the past. They need the context. They need to give you the ability to reference what happened in the past to make the best future actions. And so the Agent Memory Toolkit that we announced makes it incredibly easy to do that at scale on Cosmos DB. I'm going to get James up here, and you're going to show us how it works. Come on up, James.
All right. So let's get started. So as Charles was mentioning, we're releasing Agent Memory Toolkit as a Python SDK and also as an accelerator for generating, processing, storing, and retrieving agentic memories in Cosmos DB. So it's available in Python. It uses Cosmos DB change feed to automatically process your memories using an Azure durable function and models that are deployed in Microsoft Foundry. So let's take a look here. So here I have a Jupyter Notebook open, and I'm going to just do some initial setup, right? So I'm going to set up my asynchronous Cosmos memory client here. And then in this SDK, I can do local operations on memories, right? So as my client's running, as I have a conversational thread open for my agent, I want to keep short-term memories in the client memory, right? Because I want it to be really accessible. I want it to have low latency, reads just instantaneously from the client. Then I can persist these into Cosmos DB for advanced search and retrieval capabilities. So in this example here, we'll see, imagine that I have a user talking with a customer support agent that's having a conversation. I can add short-term memories to local storage really easily by just using the add local method on my memory collection here. And retrieving them is also just really easy as well, just from doing my memory.getLocal command. Now, if I want to persist these into Cosmos DB for long-term storage and then enrich them and turn them into long-term memories so I can perform semantic search over them, I can just simply connect to my Cosmos DB data store and then use the push to Cosmos operations. And this make sure that I can commit and persist these short-term memories into Cosmos so I can rehydrate agentic threads later on. But then also this allows me to take advantage of the Cosmos DB change feed trigger to process my short-term memories into things like summarizations of threads, of long-going threads, or turning memories into episodic, procedural, or fact memories as well. So now I can do a quick sort of retrieval from the memories in Cosmos DB. and I can use this. So I can look through the memories that have persisted into Cosmos DB here and see a simple example of that. There's also processing that I can do as well. So in a POC, I might want to execute memory processing from the client, and I can do this directly from the SDK. It talks to both Cosmos DB to retrieve memories, and then it talks to my Foundry models, both a large language model and an embedding model, to process the memories and enrich them for semantic search. And so I can see, let me print this out here again, I can see a summary of the thread that I just committed to Cosmos DB. The user asked for a quick account read on Northwind Analytics, et cetera, et cetera. So this is really cool. So I can orchestrate memory processing on the client side, or I can offload that into an Azure durable function so it happens automatically behind the scenes. There's no orchestration I have to do after I provision these resources. Next, I can also do memory extraction, where I can extract key facts and attributes from the memories and see them and empower my agents to use on hand. And then, of course, I can see down below the risks and the reasoning for why those risks are important to the customer behind the scenes. So all in all, we've seen this great solution, right? It's an SDK that allows you to do CRUD and semantic search operations in memories. You can persist those short-term memories in Cosmos DB. you can automatically process those short-term memories into long-term memories using Azure Durable Functions and Microsoft Foundry models. And then I can query them, I can do point reads on them, and importantly, I can do semantic and hybrid search over them to get the most relevant data for my scenario.
Awesome. Thank you, James.
Cool.
Appreciate it.
Thanks, Charles.
Let's go. Okay, so moving on to SQL. I'm sure many people in the room have deployed SQL in your own businesses or your companies or what have you. It's a database that Microsoft has been shipping for, I think, over 30 years now. It's incredible technology, incredibly performant, and in Azure with hyperscale, it's incredibly scalable. And so what I'd like to do now is switch straight over to Bob, get you up here. Bob needs no introduction, and Bob's going to walk you through the latest in SQL that we've done for building applications. Over to you, Bob.
Okay, Charles, let's, why don't you go ahead and go back real quick, if you could, to the slide deck right here.
Sorry, yes.
I just want to, I like visuals, Charles, I like visuals. Okay, here's what we're going to do.
All right.
We're going to build a live site support system using SQL. So I need to support transactions, SQL check. I need to be able to search incidents and run books, which are like troubleshooting guides. We can do that in SQL. I need to look at the live state of the system. I can do that in SQL. And then use AI. And I want to do that all inside the database. Okay. Here's the challenge for the Java developers. I need to do that on my laptop first, and then move to Azure, that laptop.
All right.
So let's look at the architecture real quick here.
Yeah, sure.
So basically, I got a Blazor app using Expire running on my laptop, and I've got a Copilot agent that's going to use an MCP endpoint, and it's going to use the beauty of something called Data API Builder. Zero code exposing the database as a REST endpoint and as an MCP server. And then here's where the magic happens on the right-hand side. I'm going to use something called an Azure SQL container. Yes, it's the first time you've seen it. It's brand new. We have a private preview sign-up that we'll show you when I'm done with my demo. So it's going to behave like a SQL server, but it's going to behave like Azure, actually, running all on my laptop. And notice here, Charles, in the diagram here, all the AI models exist in the container. I'm using local models, both for embedding and for inferencing. So let's go look at the code.
So this entire slide is local then? This is what you're saying?
This whole thing is running on my laptop.
Right here.
Exactly. Okay, let's flip over and look at the code.
Let's go.
Okay, first of all, inside Visual Studio Code with our extension, I want to look at my schema to show the tables. And we have a new feature where I can chat with my schema.
All right.
So I'm over here, by using the designer, I can see the different types of tables that exist in the database, like incidents and archives. It's got vector embeddings in it. It's got JSON. These run books are like troubleshooting guides, kind of everything I kind of need. Now here's what I'm going to do. Here I'm going to show you my website. It's kind of blank right now for my Blazor app. But going back over here, I'm going to insert an incident using what like the app might actually insert. Now, Charles, I know you love T-SQL. Here we go, baby. I'm taking this note from the engineer about the actual live site problem, and I'm going to use regular expression built inside T-SQL to parse out like the error message, what kind of build they're running on, kind of wait types and so forth. So I'm taking this like really unstructured text and putting them into JSON inside the incident.
All right.
So I'm going to run it. I'm going to go click to my database, run it, and I've inserted my incident. Now if I go back over here to the website, it shows up. And here's the note from the engineer about what happened. So what I'd also like to do is show you how we can do what's called a vector hybrid search. This is a stored procedure that I've written, and we're going to use the power of vectors and embeddings to go search those incidents. So over here, I'm going to use the new vector search T-SQL with top approximate to search my incident history. And then I'm going to go search my run books by using vector distance, but also combining it with a JSON index seek. So you go look at the result over here, I get a combination of the history of incidents that may look like our problem, plus troubleshooting guides. I can put all that together, and if you go look at the execution plans, you can see here, I'm using a vector index seek for that first one. Then scrolling down here, I am going to show you I'm using a JSON index seek.
All right.
I'm combining both of those to do the hybrid search. Okay, what about this agent technology? Like, how do we do that? Well, this is where it gets fun. I'm going to go kick off the actual agent here. Let me go find it right here. I'm going to say mitigate incident 512. I'm going to do this with my agent I built, and I'm going to show you how it works. So let's kick it off. Now, here's how this works, Charles. I've got a couple of files here. One, I've got an actual agent markdown file that tells the agent what are the tools you can use. That's from Data API Builder.
Okay.
Using all those tools.
Yep.
Then I also have a skill file. So I'll go over here, I've created a skill that gives it the protocol for how to use those tools, when to use it. Like for example, we don't want to go build indexes if the system's really busy, right? So you can see this is now using API Builder over here to the right, and it's using various tools to go look at the system, find incidents, look at run books to troubleshooting guides, and this is really beautiful. Look at diagnostic procedures to decide, do indexes exist? Is the system busy? And then finally calling the stored procedure to go, I'd like to go try to generate the actual plan. This stored procedure is the one inside the container that is calling AI models locally to come up with this plan. And I'm going to come back over here, and I'm going to see this beautiful actual mitigation plan. In fact,
Wow.
it actually recommended to go create an index.
Yep.
It recommended to go lower my transaction scope, and it actually gave me like a confidence level.
Yep.
Like how confident is it going to be that it's going to solve this problem? But it even gave me some verifications, like to make sure this is going to work, go run these type of things to ensure that this solution is actually going to be solved.
Sure.
I did all of that inside my laptop.
Yeah,
Every
right
single
here.
thing, exactly.
Yeah.
So let's go back over to the slide deck for a second.
All
I'm
right,
going to show you
let's take a
something
look.
pretty cool.
So
How
that
do
was
you
the
go
local.
How do you go to Azure now?
Now we're switching to the Azure architecture.
Yeah, how do you
All
do
right.
that? Well, the Blazor app's pretty, static web app, no problem there.
Yeah.
Copilot agent still works. DataPy Builder becomes a container now in Azure.
All right.
That's all the same.
Yeah.
And look, I'm just using Azure SQL Database.
Okay.
The T-SQL code that you saw to go power all this is identical to Azure, and now it's going to go to Azure OpenAI.
Got it.
Because all of our ability to use AI is using URLs.
Yep.
For the embeddings and for using chat agents and so forth. All of that code exists to go contact Azure. So making that switch from this Azure SQL container over to database is really, really simple.
Fantastic.
But
Awesome.
do you want to see how people can sign up for this thing?
Please.
Let's go to the next slide.
All right.
Here you go. If you as a developer would like to try our new Azure SQL container, we would love for you to sign up with us. Use this private preview sign up page. We'd love to hear your feedback. You need to think in terms of using a versionless SQL server now locally on your laptop that behaves like Azure SQL, but it is the power of SQL Server. And you can now build powerful AI apps like I showed you, both offline first, and then easily move to Azure.
Fantastic. Thanks, Bob.
Thank you.
Thank you. Okay, so we're moving quick today. I promised we'd go quick, and we are going pretty quick. So I want to talk a little bit about what we're doing with Postgres at Microsoft. We've been working on Postgres incredibly hard for a number of years now. We are deeply invested in Postgres, really across multiple fronts, both in what we're doing in Azure and what we're doing through the community. Postgres is one of the most successful open source software engineering projects that I have ever seen. And so while we ship services like Azure Database for Postgres Flexible Server, and we announced HorizonDB, which we'll get into in depth soon, we also do a number of other things. Microsoft actually hosts and runs the largest virtual community conference in the world. We run a podcast. We have a blog that contains pretty much everything that we do in the cloud and through our team of committers. We are one of the most prolific committers to the upstream project of Postgres. We know how Postgres works. And then we're investing deeply into tooling as well, which I'm going to show you a little bit of here. So this really is a first-class platform in Azure. We're going to walk through some of those capabilities. Now, I talked about being a prolific committer to the upstream project. This is the core upstream open source project, aside from contributions we make to other extensions. In Postgres 19, which is going to ship probably towards the end of September this year, Microsoft actually made around about 11% of the total commits to that project. We changed approximately 64,000 lines of code in the project, which represents about 8% of all changes made in this major version of Postgres. And these are non-trivial changes. These are changes directly in the query engine. Introducing a lot of the asynchronous I/O work into Postgres is coming from engineers at Microsoft, and we've done a ton of work around observability as well. Now, a few years ago, we shipped Azure Database for Postgres. You can think of this as being managed open source Postgres. It's something that we're shipping frequently, new features into, and we've really just focused this on ensuring that it meets the enterprise requirements of yourselves and our customers, things around security, high availability, disaster recovery, but then also made sure that it is compatible with the open source project so that you can bring those apps to Azure, and it's Postgres as you'd expect, and we reflect that in the sheer number of extensions that we support. Now, we've been shipping at a frenetic pace. We ship almost every month. We miss one for holidays, we bank an extra one for a conference here and there. But if you look back at the history of this service over the last 3 to 4 years, you will see constant month on month additions. It's a service that we're investing very heavily in, and we have a large number of customers who are taking a dependency on this today. And one of the things that I'm incredibly proud of in the last 4 years is the fact that we've been able to completely eliminate any cloud lag from shipping major versions of Postgres in the managed service on Azure. A few years ago, we were not great. When Postgres 15 or 16, I guess it was, dropped then, you had over a 6-month wait to get that in the managed service at Azure. It was not something that we were proud of. Last year with Postgres 18, we lit up Postgres 18 in the managed service on the same day that the community accounts announced general availability. So there's no need to develop like on your laptop, although you can definitely develop on your laptop and easily move to the cloud as well. We've got the latest bits in Azure for every major version, and we're going to try and do that again this year. Now with HorizonDB, that Satya announced in the keynote this morning, we're taking it up a level, where we make a change to effectively separate compute and storage. I'm going to get into that one in a second, but with HorizonDB, we bring new AI capabilities, AI pipelines, AI functions that make it easier to bring more of that application logic directly into the database. A lot of people debate if it should be in the database, out of the database. I like it in the database. The point is you've got choice on how you build these applications, and you can bring a lot of that core into the engine. This architecture supports up to 3 times faster transactional processing and vector search using Microsoft's disk ANN vector technology, and it scales at the moment up to about 128 terabytes with zone resilient storage, which you can sort of fail over across zones. So for more, let's check out tape.
Azure HorizonDB is Microsoft's new Postgres service that's enterprise-ready and engineered for developers. Getting started is simple. Quickly configure compute that includes powerful AMD EPYC processors, zone-redundant high availability, and storage that auto-scales to 128 terabytes. Entra ID authentication and private link networking keep your data protected with enterprise security by default. Provision from the portal or directly from VS Code. Wherever you work, HorizonDB fits your workflow. Inside VS Code, GitHub Copilot authors your SQL. The Object Explorer browses tables, indexes, and properties without leaving your editor, and the Visual Query Plan turns Explain Analyze into a tree you can actually read. For DBAs, backup management, server parameter tuning, and real-time monitoring all live in the same workspace. One tool, no context switching. Your database operations right next to your code. HorizonDB brings AI capabilities directly into the database. Disk and vector indexing provides highly performant semantic search. As applications evolve into intelligent systems, AI pipelines, AI functions, and built-in AI models provide a complete solution for data chunking and embedding generation. As your applications scale, HorizonDB is ready to go. Scale out across replicas with a couple clicks. No re-architecture, no downtime. The result is a unified platform where transactions, vectors, AI, and orchestration work together to help empower teams to build smarter applications faster with less complexity. This is Azure HorizonDB.
So there's an awful lot there. But the thing that I'd like to focus on is around the architecture of Horizon and how we've built it. The key point in this slide is that thick white dotted line straight across the middle. Everything above the white dotted line is compute. It is actual Postgres. It is true Postgres. It is the open source Postgres engine. It's not a almost compatible derivative of. It is Postgres. The apps that you build on Postgres today will just drop on top of HorizonDB and run. Now, under the dotted line is an entirely new storage engine that we've built, comprised of a new log server, wall server in Postgres terminology, and then page servers with everything back-ended by Azure Storage. And what this provides is a shared storage platform that is striped across availability zones by default. We've done a ton of engineering work, highly optimizing that log service, which is how we deliver the transactional performance of the platform. And so what I want to do is actually show you a little bit of what this looks like. Here's a classic split screen. Everything here is the same. It's the same version of Postgres. It's the same region. It's the same hardware running on the same availability zones. And on the left, I'm running self-managed Postgres on those VMs in Azure using Patroni. And on the right, I'm using HorizonDB. And we're just going to go and run the TPC benchmark to illustrate the transactional throughput. Both of these are configured, as I mentioned, for high availability across zones, the way you should run any production workload. And on the left, you can see that self-managed Postgres sits around about 4,000 transactions per second. HorizonDB sits around 11,500. I think one of those rows actually caps out 12,000. This comes down to that massively optimized storage engine that sits in HorizonDB. if you took an app that was running on Postgres today, on VMs, across availability zones, and you dropped it on Horizon, this is the type of characteristics you should expect to see with respect to performance. And so that was a core design tenet for Horizon, was that it needed to be highly performant for larger, more demanding apps. But of course, you can provision incredibly small form factors as well. Now, the other interesting thing about Postgres is that it is one of the most preferred databases for building new classes of AI apps. When ChatGPT hit all of us, a few years ago now, and we all need to go and discover what embeddings were and how vectors work and what this similarity search was, PG Vector as an extension was right there, sitting in Postgres. And so a lot of people moved and looked at Postgres for that basic scenario. Now, we've made a lot of investments since then, and we've learned a lot about how our customers are trying to build applications on Postgres. And one of the things that we've heard is that stitching these models together can be a little tricky. So one of the features that we've shipped in HorizonDB is AI model management. With AI model management, you enable it during provisioning time. And what we do is effectively pre-register a few models directly out of Microsoft Foundry. Then you can then invoke directly using SQL, using the AI functions that we've built. So we're seeing a lot of customers invoking these directly from the database, whether it's embedding generation, like Bob talked about, or re-ranking, which we'll talk about a little bit later as well. There's a lot of great ways you can bring these models and apply them in the database itself. One of the other things that I'm incredibly excited about in Horizon is AI pipelines. We built a new extension called PG Durable. It effectively implements durable functions natively in an extension in Postgres. It provides basically an asynchronous background job that can sit there watching for changes in your data. So why is this important? Well, when you insert a row of data, and I'll give you a great example, you put a row of data into a database, it can take milliseconds. It should take milliseconds, right? We need these things to be incredibly quick. But if that row contains text that we want to generate an embedding on, then that's going to take a little longer if we put the embedding creation in the commit path of that row in the database. So with durable functions, what you can do is set up a watcher on the table. Your application is writing data to the table or modifying data in milliseconds. And in a sort of more asynchronous background task, once certain change thresholds get hit, the durable pipeline can invoke the embedding model, go chunk the data, create the embeddings, store it back in the database, but your app doesn't really notice it, except for the fact that that similarity search just has a little bit of lag in it while those models are working on building the embeddings in the background. So to give you a bigger view of the code, we won't work this, I'll get Abe to walk the code in a second. You can get a sense of what the durable function does. You create it like an extension, AI create pipeline. You can see that it handles chunking of data. You can see that we're using an embedding model here. We're explaining the number of dimensions. And the batch size of 10 means that we're going to let 10 changes happen to the table before we go and invoke the batch. And that can be a performance enhancement instead of invoking, even though it's asynchronous, on every single transaction. Now, another thing that I want to talk about quickly is how deeply we're investing into tooling. You saw in the video a lot of VS Code. VS Code is, really one of the places where developers are building apps. And so what we wanted to do was bring an entire database management experience into that same environment for Postgres. And so what you can see here actually on this screen is a visualization that we've built for the pipelines that I just talked about. You can debug these pipelines visually in HorizonDB in VS Code. It's incredibly easy. When you actually open this UX, you'll see the data, the numbers churning. You'll see the pipeline running in real time, and you can see what's actually happening. But one of my favorite features is query plans. I spent an inordinate amount of my career staring at query plans. I figure if you're going to spend a lot of time looking at them, they may as well look nice. So we brought our design team to the party. We designed entirely new query plans. This is a tree view, and of course you can also have a table view, but if you have incredibly sharp eyes here, what you may have noticed is the Copilot icon next to every single operator and actually at the very top of the query plan itself. AI agents are phenomenal at debugging queries. And so directly into VS Code, we've pre-prompted it that when you click on a query plan or an operator, it will automatically generate the prompt telling Copilot what to go find. It runs in agent mode. You can choose the model that it's going to use to debug the workflow. But if you've ever run into a slow query, you've started reaching for your toolkit of queries to figure out what's going on in the database, this is a vastly more efficient way to do it. And what's not shown here as well is that we've also implemented this into real-time live monitoring in VS Code. You can launch a dashboard and watch CPU charts dance. And if something goes wrong, you hit that Copilot icon as well. And we're going to bring that into pipelines as well, the visualization I showed you before, for debugging those. So we're continuing to invest very deeply into this tooling. But I should mention, this tooling works with any Postgres. I use it connected to Postgres running on my local machine. You can connect it to any cloud, and it'll just work for everything that I've just talked about here. Now, to explain more about Horizon and these durable pipelines, we'll get Abe up, and let's take a look. Come on up, Abe.
Hey everybody, my name's Abe, and today I'm going to be doing something that a lot of people do. I'm going to create a RAG pipeline with AI pipelines and show you guys, how I can do this live on stage. So,
all right, let's try here.
Let's try it out.
Oh, that's not you. That's you.
There we go. So what I'm going to do is I'm going to do a 𝗲𝗲 Room Designer agent. I'm going to start with create an AI pipeline so it ingests all that data. Then we're going to retrieve that data. So I'm going to start right here in VS Code. So this is all live. So if anything goes wrong, we're praying to the demo gods here. So we'll start by seeing the data. What you can see is a data set of e-commerce data. So a bunch of furniture in my e-commerce shop. But how do I make this ready for AI search? First thing I need to do is I'm going to go look at my AI model management registry. Just like what Charles talked about, right in the HorizonDB database, you can see that I have access to 3 models. A re-ranked model from Cohere, a chat model, GPT 5.4, and lastly, an embedded model to do embeddings. This all can happen automatically. So basically what that means is you get to create a RAG pipeline with around 8 lines of code. Rather than having Python, an external orchestrator, external service, you can do that all in Postgres, all in HorizonDB, all in a language you're used to, in SQL. So I'm just going to run this pipeline here. Charles has gone through it, and I'll go into more detail. So I've kicked off the pipeline. It's currently running in the background right now. But as it's running, let me explain what happens fairly quickly. So we're going to start with naming the pipeline. Obviously, we're here in build 2026. Then we're going to start the source. The source I just showed you was our product sample table. Around 60 rows. It's just for this demo. It will go through all those rows, and it will do 2 things. So in the step column, it's going to go ahead and chunk the data. So most people want to chunk their data so they can find the right content at the right place, and then embed all those chunks. So what's going to happen is, in the back end, we automatically make a table for your outputs. We create the chunk text, so that chunk data. Then we send it for embedding. Then we embed those chunks for you. So now that that's explained, let me quickly check the progress of this pipeline. So we can do that all in code. So if I check the progress of the pipeline, I'm looking here, it says 0 process. So what could be happening? So let me just quickly check what's going on. Again, with live demos, let me quickly check what's happening. So right now, I'm just checking the pipeline UI. So we're going to go ahead. This is loading. And you see, so it says right now, currently the pipeline is not loading. So what I'm going to do here is just do a quick cleanup and rerun this pipeline. So let me just quickly check my cleanup script. So I'm going to drop the pipeline. Again, this is happening all live. So I'm going to go ahead and drop this pipeline and see what happens. So we drop that pipeline. I'm going to rerun this thing to make sure it works. So going to go and do this rerun. So
we create the pipeline first.
Yeah, so I
and then
create the pipeline.
That's just creating the object though, right?
Exactly.
And then afterwards you explicitly run it.
Yes.
Which is that step there. Okay.
So I'm explicitly running the pipeline. So now that's being run. So I can go back to that dashboard I just showed you to show you that that actually got run and it didn't fail this time. So go back to this kind of dashboard here. You can see it's loading, bringing all that data in. And you're going to see I dropped that table. It's going to get running again. Oh, it looks like, oh man, this is...
The failing again, Abe?
Yeah, it's failing one more time. But luckily, I already had a backup. So I have a backup that has already run successfully for this demo specifically. So in this backup right now, what I'm going to show you is how the pipeline runs. So directly in the pipeline, we can see that, let me zoom out one little bit. So we can see directly in the pipeline, what got run was we took the product sample table, we took the content as I showed you, we chunked that text, and we talked to the AI, to the model management that was running. So, and then lastly, we put that on the output. So the output table is the backup pipeline I had running just before this. So what's happening, I think there was just a conflict in me running this on live on stage, but the backup has it. So now the backup has my table that saves all the data for me to kind of process this pipeline.
And so Abe, it's also important, that text embedding 3 small, that came through the model management.
Yeah,
so that was available to you simply by provisioning HorizonDB. Right? You didn't need to crank up Foundry and do all of that additional work. That handles automatically by just provisioning Horizon, enabling the AI features.
Exactly.
Okay.
So what I'm going to go ahead and do is I'm going to go and run this just so you guys see what happened. So what I'm going to do here is from the output right here, let's skip this part right here. I'm just going to show you guys what that output looks like. Hopefully this works. And this is, all right, there we go. So you can see in the output table, what actually happened is when that row got created, it saved the IDs of all those products. Then it saved the chunks of each product. And then with all that chunk text, it saved those embeddings. So if you click into it, you can see what happened is right in that HorizonDB, it embedded all those chunks. And now you can do an AI search on that chunk. So now that we have that kind of up and running, right? Another thing I want to show you is that directly in VS Code itself, you can go ahead and now do that search. So looking at that table, I'm going to go ahead and search. So the thing I'm searching right now is, okay, let's see what's going on. Yeah, obviously it's not working because it's not looking at the backup table. So I'm going to just change this to the backup table that we were working with. Going to do a vector search on this, and then
where's our create embeddings? You got the right database?
Am I pointing to the right database? Sorry guys, it looks like, let me try the backup database really quickly. And then let me try this again. I should have something similar running there. Let me just run this again. This is supposed to go smoothly. All right, so, okay. So as you can see here, I'm doing that search, and that search is running on the backup, just looking at that embedding, and in the embedding, I'm searching for comfortable chairs. And you can see right here, it's giving you a search right from that database. Now it's AI-enabled to search, and it's searching through my chunk text column. So it's finding things that are comfortable, so like comfortable stylish chair, recliner chair, the massage chair, so on and so forth. So just to kind of understand a little bit, more on exactly how that happened, right? So as I kind of walk through the pipeline for y'all, you guys have seen that pipeline running. So I just want to show you guys what happens if I were to insert a new table to kind of the backup pipeline. So we're going to go back to the backup pipeline. And then what happens, let me just kind of show you. So what happens when a pipeline, a new row gets inserted. So I'm going to go ahead and insert a new row to my product samples table. So that got inserted. And that's running right now on, I think it's running on our backup cluster, which is, yep, that's what got run. And then what I'm going to do is check that backup cluster, which I also have here. Let's open in databases, check the pipeline UI, just like before.
So it's noticeable when you inserted that row as well, like I know we're going to go through the pipeline, but the row inserted in milliseconds.
Yes.
That's what we were saying before. Like you get this asynchronous behavior where the OLTP throughput of the database is sustained, and then the after work to create the embeddings, which is intensive both from computation from running the model and the latency of making those API calls, kind of gets hidden away because it sort of happens after the fact.
So you can see here, that job got kicked off 49 seconds ago. So what got inserted is now running the pipeline on the background. And just so you guys know, all that is done on PG Durable, like Charles mentioned. So if you were to go to Microsoft/PG Durable, you can see this is all fully open source. You can go ahead and build your own type of PG Durable functions directly into Postgres. And now that you know that that pipeline has kind of run and is complete, and you want to do something similar, like if you want to do something similar yourself, you can use PG Durable, but in HorizonDB, we have the pipeline, and then now we have the output table we can use to do some searching. So what you've seen is we've done the data ingestion. It was a little bit clunky with the error, but we used our backup cluster. And our backup cluster, we're able to create a pipeline. The pipeline outputted a table, and you guys are able to see that table, the chunk text in the RAG output, right? And now what we're going to do is we're going to do data retrieval in that output table.
Okay.
So what just happened is now I'm just going to switch the backup cluster because that's where we had things running. So now that I've switched over to the backup cluster, we're going to do the same things. We're going to, first thing, I'm going to create a full text search index on that. So what that's going to do is I can do PGFTS's Postgres full text search. I can do a full text search on any query that comes in. And then I can also ask diskANN. So what the diskANN index is doing is for all the vectors we created in the embedding column, I can now have faster search. So what we've added is something that makes searching on your corpus fairly easy with AI. So we've added something called AI search. So this comes out in June, so I hand-rolled to a custom function just to show you guys how that works. And what you're going to do is you're going to put in your query. And the query right now is I want mid-century furniture for my Brooklyn apartment with dark wood tones. I'm going to search that output table we talked about. I'm going to look at the chunk text column for the full text search, and I'm going to do a hybrid search and all of that. So I'm going to go ahead and run this.
So that hybrid is the combination of vector and full text, right?
Exactly.
Okay.
Vector and full text. And you said you'd really like the query planner, right?
I love query planners. I spent a good chunk of this session talking about them.
The cool part about HorizonDB and also the VS Code extension is I'm going to go ahead and just let me redo this switch this really quickly. Let's rerun this query plan, and then I'll look at the backup pipeline. We'll run the search because a lot of this stuff already, the create embedding on that is absolutely not working for us.
Also a useful advertisement for IntelliSense.
Yeah, so
built into VS Code
exactly.
as well.
So we're going to go back to the backup. Just try this one more time.
Right.
So what happens with the query plan is we can do the AI search, run that. When we run that AI search, I'm going to go ahead and do the query plan on that. So yes, so right in the query plan, we can see all the queries, like the full text search running, and then we can see the sequential scan running. And right in all of these nodes, we can debug exactly what's going on inside my hybrid search. So as you can see there, we were able to do the pipelines for data ingestion. We're able to do the retrieval for your Postgres database. And then lastly, the last thing you might want to do is integrate this into an agent. I'm just going to do the last section here, Charles.
Yeah, let's go.
The ingestion has all the stuff, and then we're doing the retrieval. We asked the agent to design this room. So we're going to do the search. We designed the room by searching that data, using the AI search and hybrid search. And then when we look at the agent, what the agent was able to do is talk to all these HorizonDB tools. So it can do the hybrid search for AI search. It's going to analyze the room with the GPT-4 model it has, and it can then curate your picks using the hybrid search. The model will re-rank the results and give you furniture in your room that matches the style of your room, and you can go ahead and buy all that furniture.
Fantastic. All right, and all of it's in Postgres.
Every single thing you saw, your entire AI stack is running right in Postgres. So
all right.
let's just switch right over to the last slide.
Thank you.
So as I showed, it looks like in the backup cluster, you can see we built an AI native app all in Postgres. Your data was ingested in Postgres. Your data was retrieved in Postgres, all your data. And then lastly, we had a graph to connect everything, and then built all with models living in the AI model management. So
awesome.
That's it. Charles, thanks for
Thank you.
letting me demo that.
We got through a lot. So let's start to wrap the session up. We talked about a lot today in 45 minutes. We covered Cosmos DB and the memory agent and how it's easier to build that class of app. Bob showed you SQL, announced the new local dev container, and how you can build locally and move that to the cloud in SQL Hyperscale. And then Abe really took you through an end-to-end in HorizonDB for using AI for both ingestion and search. Don't forget that all of the code is available in GitHub. If you missed this at the start of the session, grab a photo right now. It's all there and more, I promise. I'll give that a split second while cameras come down. There's a ton of other great sessions, so there's a lot of additional talks that we're giving on HorizonDB. It's something we've been working with a lot of customers for a long time now. We're super excited to get that into public preview. And then to wrap up, we'd love you to do the evals if you get a chance. And aside from that, that's everything we had. So thank you for your time and enjoy the rest of the conference.